This is example 21. The figure shows a force of F equal to 100 Newton applied in a positive Z direction at the point Q 111 of a cube whose sides have a length of 1 meter. So this is the cube here, this is the force here, the force is 100K in the Z direction, and there's a point Q where the force is add on, and then assume that the cube is free to rotate about the point P, which is at the origin. So there's a point P, this point is fixed, and the cube is free to rotate about this point. So the question is, okay, find the scalar moment of the force about P. Describe the direction of rotation. Let me explain what is meant by moment of the force. Moment of the force is equal to R cross F, where R is the vector measured from the center of rotation, which is P. This is R. Where F is the force acting on the point away from the center. This is the moment of the force. So this is the vector product. And then describe the direction of the rotation. This is basically telling you where is the axis of rotation. This is because when the force F acting at the point Q and P is fixed, then the cube will rotate. So because the cube is rotated now, we want to ask what is the axis of rotation now. That is why we have this kind of question. You can find the information required in the notes. And this moment of the force acting on a point about a fixed point, this is called the torque, which is a vector. Torque is equal to R cross F. Okay, when you have R cross F, because this is a vector product, you know the direction of R cross F, the vector perpendicular to R and perpendicular to F. Okay, let's do the calculation. The torque, which is R cross F, where R is a vector from P to Q, which is 1I plus 1J plus 1K. And the force acting on Q is 100K. So let's use the 3x3 determinant to find out your IJK. In the first row, R on the second row is 1, 1, 1, and F on the third row is 0, 0, 100. So we expand along the first row, then you get this is I times determinant of 1, 1, 0, 100 minus J determinant of 1, 1, 0, 100, and K, determinant of 1, 1, 0, 0. And this will give you 100I minus 100J, and there is no K. This is the moment of the force about P. Okay, moment of the force about P. Then, what about the scalar moment of the force about P? This is actually the magnitude of the torque here, which is equal to square root of 100 square plus minus 100 square plus 0 square. So there will be 100 square root 2, and the unit of this torque is meter Newton. Since the force is measured in Newton and the length is measured in meter. The last part of the question is try to answer the direction of rotation. Okay, this is a direction perpendicular to R and F, where R is this vector, F is a force acting at Q. The axis of rotation is find out what is I and minus J, right? So you have 100I times I minus J. What is actually I minus J? So I is a unit vector here, I. J is over here in the negative y-axis direction. So this is minus J now. So I minus J, when I add them up, is actually this vector along the plane I minus J. So this is actually the axis of rotation when the cube turn, because of the force acting here, so they actually turn around the axis. Okay, the axis rotation is in the direction of I minus J. So I hope this will answer the question. As the force acting on Q, as P is fixed, the Q axis turn around the axis I minus J. And I minus J is perpendicular to both R and F.